call in 2020, that was the SPILE 07, preserving fresh waters, recycling industrial waters, and that supported 5 projects. It has been quite a prolific call for proposals. And it funded, 5 important projects that look at what? They look, to achieve, important goal, which is the near zero water discharge, through what? Through integrated water smart strategies for the industry, for the industrial processes. Today we are here in a clustering event. We have the coordinators of the project. We have the project officers of the health and digital executive agency of the European Commission. And we are here together to discuss the achievements so far, the barriers, the synergies, and the perspectives from each project that we are going to present today. This is, a snapshot, really, or a snapshot of the speakers that we are going to have today. A very quick tour, across the agenda. We have part A, where we introduce the topic. We have a presentation from Adair. We have a keynote speaker, a speech from Ludo Dills. Then we have the part B, which is dedicated to presenting the 5 projects from Axel Water up to Waste to Fresh. Then we have a final part C, that is a panel discussion on synergies, the common barriers, possible developments, policy implications, and with question and answers that can come from the audience and, of course, from all the panelists. Now, some domestics, which is also important to highlight. For the speakers, please do not exceed your time allocation. So stay within the time that you have. For the audience, nobody can speak. Whoever from the audience is muted, but you are really welcome to address questions on the chat to the speakers. And in the panel discussion, we would ask the panelists really to react each other. The result of this session should be like, really a kind of TV debate. What else can I say? Let's get started. And I stop sharing my screen, and I'm really honored to leave the floor to Susanna Xara from the Adair for the presentation from the executing agency.
Susanna, you're muted.
Thank you very much, Andrea. I'm trying to share my screen. I think that you can see it now. May you please confirm?
We can see it.
May you please confirm?
Yes, Susanna.
Okay. Good afternoon to everybody, and welcome to this session. I'm Susanna Xara. I'm a project advisor at Adair, and this afternoon I'm delivering this presentation on behalf of the 5 colleagues that I will introduce later, that are in charge of the 5 projects that are funded under this call Horizon 2020 CE SPIRE 07 2020, entitled Preserving Freshwater, Recycling Industrial Waters Industry. So the logo of these 5 projects are indicated below, and they were already mentioned by Andrea. And the objective of my talk today is to introduce you Adair, the European Health and Digital Executive Agency. So we are one of the executive agencies established by the European Commission. So we are part of the European Commission. And particularly this agency is very new. It was established in the 1st of April 2021. And we are in charge of managing European programs and initiatives on behalf of the European Commission. We work very closely with our parent DGs that are indicated here, DG Connect, DG Defis, DG Grow, DG RTD, and DG Santé. And these DGs are the leaders of these programs and initiatives. And all of them are focused on legislative and strategic tasks in policy making. I would like also to introduce you the Adaia's vision. And our vision is to boosting Europe by building from earth to space a healthy society, a digital economy, and a competitive industry. So this agency covers different sectors, including health, food safety, space, industry, and digital. This part of raw materials, where this topic of SPIRE belongs, is under the sector of industry. On this slide, I want to show you the budget that is allocated to the different programs that we are managing. And as you see, Horizon Europe Health Cluster corresponds to a big part of our budget. Then we have EU for Health, also with a very relevant component of the total budget. The single market program that covers the food safety, particularly. Then the Connecting Europe facility, the Digital Europe, and then the part where we belong, it is the Horizon Europe Digital Industry and Space Cluster. So we have, as we see, the biggest part of the budget allocated to Adair, the Health and Digital Executive Agency. So our role, as most of you already know, covers the entire life cycle of the projects, starting from the evaluation of the proposals that are submitted to each call. And after that, we select for funding certain proposals, always the best ones. And with that, we prepare the grant agreement, and the proposals on that time, they turn into projects. After the grant agreement, the signature of the grant, the consortium starts the implementation of each action, of each project, and the project advisors, we are in charge of doing the follow-up of the implementation of these actions. After that, more at the end of each project, but for some of them also during the implementation of the project, we contribute to the policy feedback, and we support the projects, particularly in the exploitation and dissemination activities of their results. So we manage the entire life cycle of the projects, starting from the proposals, as I said, for the different EU programs that I mentioned before. And we also contribute, as I also said, to feeding into the policy making process, the project outcomes, and particularly the success stories. This is the team that I'm representing today during this presentation. They will have the opportunity to participate during the slot that is allocated to the discussion. Carolina Rodrigues is in charge of the project Acel Water. Dimos Parasquevas is in charge of the project Aquaspace. I am in charge of the project Waste to Fresh. Hugo Miretti is the responsible for the Intel Watt project, and Yolanda Alvarez Galego is the responsible for the project Highways. As you know, for us, it is very important that you communicate during the implementation of the projects, the different outcomes and the activities that you are organizing. And for that, I indicate on this particular slide, the contacts that you can use regarding or related to Adair, as well in different platforms, including Twitter and LinkedIn, as well as the contacts for the European Commission, including even more platforms. I thank you for your attention, and in case that you have any question regarding this presentation, please feel free deliver them.
Many thanks, Susanna, for this important presentation that really gave the right picture of the Adair, being also in a new agency with a lot of challenges and a lot of responsibilities, including also the matter that this agency is going to feed into the policy making process. Having the support of the project. So it is the P4P approach, this project for policy, which takes place in the real life, which is extremely important because we can really learn a lot from the project experience in order to give inputs to the policymakers. And of course, I thank you and all your colleagues from the Adair. I'm very pleased to have you all here. And now, I would like to pass the floor to Ludo Dils, with us, a keynote speech on the role of the industrial water recycling in the process for planet circular economy strategy. Just an additional word about Ludo. I know that since years now, and I think that Ludo is also a person who knows well Spire, the transition to process for planet, and I think that he can give us some important insights on what's going on now with the new partnership. Ludo, thank you very much for being with us. The floor is yours. Thank you.
Thanks a lot, Andrea, for this nice introduction and for especially for inviting me to give a short overview about the role of industrial water recycling, and I would like to focus on the word recycling in the process for planet circular economy strategy. I think an initiative as today is extremely important. As you mentioned, it is not just a presentation of 5 projects, but it's a presentation and exchanging of ideas in an integrated way. And if we speak about integration, that's for us as the process industry, one of the most important points, as you will find out in my presentation as well. For us is integration, cross-sectorial working, etc., extremely important, and maybe the only way to really reach circular economic strategy that is also competitive. So in that way, I'm really very happy that I can share a little bit our ideas, how we see it, and how we are looking to circular use of water, etc. As you know, we are dealing with at the moment 10 sectors, which is cement, steel, chemistry, refining, pulp and paper, ceramics, minerals, non-ferrous, engineering, and finally water. So it really makes sense to make as much as possible this integration. So I will really try to give you a glimpse of how we are looking forward, and I will only, of course, limit myself due to the limited amount of time to the elements that are completely linked to water. So we are dealing, in fact, with 3 problems, and linked to the 3 problems, we put forward in our agreement with the Commission 3 ambitions. And the first one is the fact that we as an energy-intensive industry are responsible for more than 750 million tons of CO2 in Europe. And so our ambition is to bring that to climate neutrality, so to completely remove these ambitions. When we look to water, at least, and this is a little bit a tricky calculation, I think we have in our SRIA that about 6 million tons of CO2 are linked to the electricity that is used in water treatment. But we also may not forget that in a lot of situations of water treatment, we also emit so-called process emissions due to the fact that we produce CO2, nitrous oxide, etc. So this is for us extremely important, and in everything that is done in every project, we would like that some focus is going on one hand to this energy reduction, but on the other hand also to ways to change water treatment so that we have less emissions as well. The second point is that we try to work on, or we try to to use at least 50 to 60% of the waste that is generated in Europe as secondary resources for us. For us, it's extremely important that we can use these waste and bring it back as a secondary resource and not to leave it as a waste. Speaking again about water, then I think that at least we have to take into account about 13 million of industrial effluent sludges and about 10 million of sludges and liquid wastes coming from waste treatment. So that's certainly the minimum, but this can be either reused as a feedstock for materials, but either also as a feedstock for our energy consumption. And then the third ambition is competitiveness. And there our ambition is really that we stay competitive during the whole period of this transition, but in the same time that we create a gross added value that will be for the process industry that will grow quicker than the EU GDP. So really ambitious. We are not just willing to survive, but really to grow and to go for a really strong process industry in Europe. When we look to the materials flow in our industry, then we see that we use primary resources that via the process industry are transformed into materials. This is used by the manufacturing industry to make products. And then as a consumer, we bring it to the end of life. And then via the recycling industry, it goes back to the process industry as secondary resources. Of course, we will interact as a process industry at several levels of this process. But speaking about water, then for us, the recycling of the water in the advanced processes with resource efficiency, where we also recover the resources, including energy, and where we try to recycle the water are the most important. Also, we would like to mention that the secondary resources, so coming from the recycling industry, are in many cases making use of water for cleaning, for washing, etc. So also there, we would like to see this link very strongly made so that we really can close this water circle. If I can translate that into challenges, then I must say that up to now, in water treatment in general, we have a lot of attention to oxidative processes, but not that much to reductive processes. And oxidation always needs a lot of energy. So it's certainly a point to take into account. Up to now, there is still a limited amount of water that is nowadays recycled really in process industry. So there's a long way to go, and we really look forward to nice projects where we can improve this potential. Needless to say that nutrients recovery, for instance, phosphorus due to the scarcity that is coming, but also energy due to the fact that there is a lot of nitrogen, linked to the energy due to the fact that we need a lot of energy to make it is extremely important. And in general, I can say that solutes recovery, chemicals, metals, and among them CRMs, but also salts, etc., are key if we want to close the circle in a circular economy and we want to keep our feedstocks. In addition to that, I think it's important that we can also remove toxic elements out of the system. We do not want to go to a circular economy where we circulate also the toxic and hazardous compounds. This must go out and go into a safe sink in a certain way and will not be kept anymore in the circular system. Also fit for use, which was an expression coming from WSSTP, is really important. And there we make a lot of links to sensing to understand what kind of water quality we need in our processes and to sense the water quality so that we can optimize the treatment in function of our processes and don't have any risks in the processing itself. And finally, I already mentioned it, we have a link to recycling industry, for instance, in paper recycling, but also in plastics recycling, etc., where a lot of water is or will become used. And so that really makes sense as well for us. If we look to the energy, of course, energy for us is extremely important, but taking into account water, then energy efficiency in the processes is of high importance, because there we can really make a big difference. And in that way, also the reuse of excess heat in order to dry, to evaporate water, to reduce, to increase water, to increase solubility or whatever, really can make a big difference. So linked to that, we can say that nowadays more than 6 million tons of CO2 are emitted due to electricity use. Half is coming from aeration. Oxidation is done with air, which is not at all an energy efficient system. We blow too much air in our wastewater treatment systems. Of course, we have a lot of nitrous oxide and CO2 that is emitted. Again, I would like to say that we focus up to now to oxidative processes. Again, this fit for use is important because there is also a link to the energy use in the water treatment. And here I would like to make or to break a lance even for the water energy nexus, and not only at the level of heat in the water, but also at the level of carbon related energy. I mean, if we destroy just the carbon in the water and don't use it as an energy source, then we will need a lot of energy. We can calculate that about that we need about 1.5 kilowatt hour to destroy 1 kilogram of COD. You can also reverse it and then produce 1.5 kilowatt hour. So this really can make a difference. Finally, process efficiency and intensification, for instance, energy efficiency, watering, etc., also makes a lot of sense in our different processes. And then as a third point, I would like to bring up the hubs for circularity. And in the hubs for circularity, we try to connect geographically close units to keep the resources in the loop as long as possible. And that for us is really the basis of integrated process industry, of integration of all kinds of flows, and among them, water is one, of course, of the mainstreams in that, maybe the most easy to keep completely in the system. And with that, I would like to show that it is not just per factory or per plant that we are looking, but we are looking really to these integrated systems. So industrial symbiosis in a cross-sectorial way, and also not only cross-sectorial towards the sectors of P4Planet, but also to manufacturing sectors, recycling sectors, etc. But also the integration with urban industrial symbiosis. So that's a point that we really want to put forward, where we see a lot of potential to improve, maybe other forms of symbiosis. And really the closing of the circle does not per se mean that we close one process, but we close it in an integrated way. And of course, we have a strong need for integration with other sectors for waste heat, energy, integration of waste recovery, etc. So it's going further than just the sectors of P4Planet. Having said that, of course, it's quite important to show you that the different projects that are now operating under the Spire call are really taking this into account. We see accelerating water circularity, innovative water recovery solutions via recycling of heat materials across different sectors, advancing sustainable and process industry to digital and circular use innovations. Also, this digital is extremely important. And then intelligent water treatment for water preservation, containing simultaneous energy production and material recovery in energy-intensive industries. And finally, smart, innovative systems for recycling of wastewater and creating loops in textile manufacturing. Having said that, you already see that we speak a lot about energy-intensive industries, but also you see food, beverage, textile, which are not sectors of P4 Planet, but where we really also are looking to this integration. And based on that, I can say that now we are preparing work program 23-24. So for the future, we are still in a very early phase, but I would like to give you a little bit of a glimpse of what we are looking for. So we are looking really for sustainable and efficient industrial water consumption with zero pollution goals. Really, you want to go to zero or near zero pollution, adopting more efficient production processes. Again, a lot of attention to smart sensing and monitoring. These digital approaches will become very important. Decision support systems for water reuse, risk management models, and I cannot repeat it enough, energy, nutrients, water, salt, solutes, everything we really want to recover in order to make our feedstock circles closed. And then, of course, we have this integration over the different sectors with also with the urban systems. Having said that, I think we want to minimize as much as possible water intake and water discharge, and we want to minimize as much the emissions and the waste discharge, and also to go as much as possible to renewable energy and to reduce as much as possible at the end the overall energy that we will need. I would like to thank you for your attention, and of course I would be happy to answer questions or to discuss further in the afternoon. Thanks a lot.
Thank you very much, Ludo. Crystal clear, there is the need for synergies, there is the need for systemic actions, there is the need of putting together the different sectors and making them speak one another and collaborate one another in an effective manner. And also from all the Europe, we have been inspired since ever, and we are close to the planet as well. And I think that also our contribution, could be important. Because we advocate for having, a water smart society. In this water smart society, collaboration and synergies is essential, and that's the reason for which we promote also the program for the water-oriented living labs. And thank you so much, Ludo, for your presentation. Thanks a lot. I think there will be questions in the discussion session. Now, we enter into details of the projects, and I'm really happy to call. This is Siropoulos from Axel Water, is the coordinator of Axel Water. Is a project that aims at accelerating the water circularity in the food and beverage industries. This is the floor is yours.
Thank you very much. Nice to meet you all. Unfortunately, COVID doesn't allow us to make this meeting in a physical way, so we will make it like that. And sorry about the mask, but this is the rules here in Greece that when you're at the company, you have to wear your mask. So unfortunately, I have to be like that. So let's go to the presentation. Okay, I think I'm experiencing a small problem. Let me share all my desktop, because why this is happening? Wait a moment, please. Okay. You are seeing my screen, but I don't think that you can see it as a full screen. You can see it as a full screen.
Yes, we can.
Yes, it's okay.
We don't see the presentation mode. Probably you can change it.
Not yet.
We can see the slides, but
not presentation mode.
It doesn't doesn't give me the option to see the full to project the full presentation. I don't know why. Before in the test everything went well. Anyway, I will try it like that if it's not a problem.
No problem.
no problem.
And I will minimize this to tell you the truth. So, okay, it will be better. My name is Siropoulos. I'm the coordinator of Axel Water. I'm from a company an SME company held in Greece called Akenso. and we are very active in agriculture and water issue things. And for this reason, we are also members of Water Europe the last 3 or 4 years, if I remember well. Now, regarding the project, it's called Accelerating Water Circularity in Food and Beverage Industrial Areas around Europe. You will see more details later on. It has a budget of 9.5 million euros. It started 1 year ago, and it will end in 3 years. Regarding the project, sorry for seeing all these letters very small. I apologize for this. But the biggest problem in, let's say, in the industry, we believe that it's the food and beverage industry, because it consumes the 56% of the available water for the industry and for urban use. Of course, agriculture is the bigger, let's say, the bigger usage of water is be done from agriculture, which holds the 70%, but from the rest, 30%, the food and beverage industry is consuming the 56%, which is a very big number. For this reason, we try in the food and beverage industry to recycle the water and to try to create some other products also. So our main expected results will be to create some new water reclaiming and reusing technologies, some valorization technologies, some energy recovery and reuse technologies, some modern ICT tools together with artificial intelligence that will help on optimizing the processes. And we will establish the water waste energy nexus for circular economy and environmental assessment of our experiments. If we want to see what we are doing, we have 4 big pilots in 4 European countries. The biggest pilot is in Greece, where 3 industries are involved. One, it has to do with the brewery, the second one with dairy, and the third one with the creation of superfoods. The second pilot is in Spain with meat processing demonstrator, the third one in Italy with tomato processing demonstrator, and the fourth one in Iceland with fish processing demonstrator. We try to have, let's say, all the types of food and beverages industries into the project, and I think that we manage that because we have 6 different sectors of the industry, of the food industry. If we want to see which was the enablers, I think the enablers for going into this project was all the new technologies that are creating every day. Okay, so we're using some technology for water reclaiming, for wastewater management, for rainwater harvesting, or for creating energy, etc. But if I want to speak about the barriers, the biggest barriers, I think, at least for the Greek side, it's the bureaucracy, and that let's say, the governments are not ready, or they were not predicted that such technologies will arise. So when we are speaking about we have to do this, that, and that, we have to take too many, let's say, agreements from the government in order to apply these technologies, because they don't know what we are speaking of. So they don't trust them. They don't, have a clue what it will happen. So the difficult barrier for us is, to try to convince them that this works and this have to be included into the national, let's say, strategy. And this happens too much here in Greece because we have the biggest site, so we have the most technologies that they have to be developed. Regarding now the Green Deal that the European Union wants for the 2050, I think that the demonstrators targets in the water and energy saving, the reduction of processing waste and environmental footprint, the creation of new products, and many more, but it's smaller one, so I will stay on that. This is some of the regulators and directives that we are using. okay, into the project in order to go into that. Of course, we have one country which is outside European Union, Iceland, so it has some other type of directives and laws, but they are familiar with European Union one, so there is no problem on that. And if I want to conclude on the project and what we have seen so far, because we are only at the first year of the project, I want to say that it's very interesting to see that the industries are very helpful on proceeding into the project and into the ideas. They want to see that ideas, they want to become more environmental friendly in general. So, because for us, when you are going into an Horizon project, which is mostly for research institutes, and the companies and the food industry are not so experienced on that, you are believing that you will see some barriers on that. But we saw that the industries are very, very helpful, and they try their best in order to achieve the best possible result. Moreover, because at the first year, a lot of job was done for creating the user requirements, we saw that in the food industry, most of the problems are common for all the types of the industry. The third one is that we tried to make let's say, a way to optimize, let's say, the project results and the project outcomes. We tried in each country to have at least one industry and one research institute. This helps in order the industries to have the necessary support for applying these new technologies. And we believe that the solutions that will be developed will be adopted in other also industries of the food industry. And of course, our goal is at the end of the project to continue this project somehow, and some of the technologies that will be developed to go to a TRL line, to a business, let's say, level, and to create some commercial products. That's all for me. I think I was on time because we have very limited time. If you want any more information regarding Axel Water, you can ask later on the last session that we have this discussion. And of course, you can send us an email. You can visit our site to subscribe into our newsletter and to be informed about everything that we are doing. Thank you very much for your invitation.
Our pleasure. Thank you so much. This is for your presentation. I mean, you pointed out, I mean, important issues, I mean, in your presentation and comments. And now, I mean, we shift from the food and beverage to the digital world of the industrial treatment, water treatment. And I'm really glad to give the floor to George Arampatsis, who will present Aquaspace, of which Water Europe is also a proud partner of the consortium. George, the floor is yours.
Thank you very much, Adair. Can you hear my screen in presentation mode?
Yes, but it is not in full screen.
Not in presentation mode, you mean?
Not in presentation mode.
Let me try again. It seems that I collect. Now? Now, Andrea, you are muted. I'm sorry.
No, it's better. I mean, but I see kind of black window on the right.
Black window on your right.
Yeah.
No, it's also on the left. Is the size of his screen. It's okay. It's in full
probably
screen.
The size. I'm very sorry because my screen is ultra wide. So
yeah. No, it's good. It's good.
I cannot do something about it because when you put in presentation mode, it takes the whole screen. And yeah, I know that. I'm very sorry about that. So thank you very much, Adair. We are going to discuss about Aquaspace. I'm George Arampatsis. I'm from the Technical University of Crete School of Production Engineering and Management. And I'm going to discuss about Aquaspace. The name is Advancing Sustainability of Process Industries through Digital and Circular Water Use Innovations. This is very important, as Adair said before, because this project combines both the processes, the circular technologies, the circular practices, and the digital innovation. So some information about the project. The project is participates in the project 29 partners from 12 countries. And there are 6 case studies. It's almost 11 million euros, the EU contribution, and it lasts 3.5 years. However, we asked for an extension for half a more year due to COVID situation. The coordinator, I'm not the project coordinator, the coordinator for the project is from the Aachen University and Professor Thomas Wittgens. However, we somehow coordinated together because I'm the technical coordinator of the project, and we both work together in the coordination part. You can also see the project website. You can visit it and take any other information you like. Now, concerning the project, let's say that the main value proposition of this project is towards a sustainable use of water and probably a circular approach for industrial applications. That means that we are now in a situation where we realize that either we rethink how we use water or we threaten its availability. And even though there is overall enough water to meet the world needs, it's necessary to make changes in how water is used. After that, the core objective of Aquaspace is to materialize circular water use in European process industries, fostering awareness and resource efficiency, and developing compact solutions for industrial applications. The main specific scientific and technical objective has to deliver a methodological and technical water efficiency enhancement framework, also to deliver methodologies and tools as a service to support the assessment and optical application of novel practices in water recovery, for water treatment and recovery, methodologies and tools to support the application of advanced water treatment and recovery technologies in industries, a monitoring platform to ensure the continuous acquisition of reliable data and cyber-secure data and commonized data from the industries, and also a virtualization, that means a digital twinning, it's a modern term, of water use recovery reuse processes and their relation to the production system and its value chain. Aquaspace is driven by several business cases in the process industry, and its innovation are focused on the deployment, assessment of state-of-the-art water treatment and recycling technologies and practices and then the concept of the water cyber-physical system explained later in 6 case studies. The first case study corresponds to 2 industrial sites of Dow Chemicals, one in Berlin in Germany and the other one in the Dauternozen in Netherlands. And this case is mainly focuses on technological innovation for freshwater reduction. The second case is in the peroxide production unit in Solvay in Italy. And this is also a very interesting case because in this case are also engaged the local municipality and also the consortium Aretusa wastewater reclamation plant, and there are actors behind that. So it's a case study which has a systemic view and the water management situation. The third case study corresponds to the sustainable and robust water management in BASF, located in the industrial zones of Antwerp. And it also has 2 sub-cases, one having an objective, the reduction of freshwater intake from for the mineralized water production. And the second one is about real-time water quality, mainly salinity monitoring and control of the different water sources. The fourth case corresponds to a waste to fuel transformation plant. It is of GEMS, located in Ljubljana, Slovenia. And this plant transforms any hydrocarbon-based waste into high-quality synthetic diesel. And the fifth case is a very interesting, also corresponds to the holistic water treatment and reuse practices in a meat industry. It's called Agricola. It is located in Romania. And also A circular linkage between this case study and the previous one 4 is also used in Aquaspace, where input material, where byproducts of agriculture are used as input material for GEMS and the waste to fuel transformation unit. The last case corresponds to an oil refinery, a big oil refinery, Tupras, which is the largest enterprise in Turkey, and corresponds to the reuse of the wastewater streams that are generated in the refinery processes. It seems that, okay. Aquaspace, as I said before, develops, integrates, demonstrates, and finally offers innovations in 3 different pillars: the circular, process, and digital innovation. Process innovation corresponds to a set of advanced technologies and practices, combining energy, substances recovery, where they are installed, operated, and assessed within Aquaspace, will be installed, assessed in Aquaspace case studies. The circular innovation is also very important, where closed loops, including the water reuse option at different levels, I explain that a bit later, in processing factory, industrial symbiosis, cross-sectorial case, those closed loops are established and assessed. And also offers, this is important, digital innovation, where the novel concept of water-specific cyber-physical system, we call it water CPS, is developed, which synthesizes digital twins of the industrial value chains, and of course, of the identities for advanced water-saving technologies. Also, water CPS and the digital innovation brings cognitive manufacturing methods and tools in the water domain, and the example that has been developed in industry in other cases brings this cognitive manufacturing for detecting non-optimal water reuse dynamically, and goes to process adaptation dynamically. Also underlying the water CPS, there is a real-time monitoring platform that connects the physical to the digital world through smart sensors, IoT devices, edge technologies, all these things. Some specific outcomes from Aquaspace include, more or less, what I said before: contemporary water reuse practice and technologies, flexible decision support methodologies to assist in selecting, configuring, and optimizing the fit-for-purpose treatment technologies, assessment using different indicators such as water footprint, embodied energy, carbon footprint, etc. Methodologies and tools to evaluate and monitor water symbiosis, because of the symbiotic actions there. Methodologies for some systemic analysis, more systemic analysis, also including a novel dynamic life cycle assessment and cost assessment. Dynamic meaning based on the data that comes from the real-time monitoring platform, and finally from the sensor in a dynamic manner, not a static one. We also, in Aquaspace, new business models are offered, will be offered, still at the beginning of the project. Flexible real-time monitoring platform, as I said before, and also the innovative CPS, the water CPS, focusing mainly, what distinguishes the CPS, the cyber physical system, that it's focused mainly on the efficiency of the water. Now, Aquaspace contributes to the European Green Deal goals and to the new circular economy action plan in various ways, offering, for example, significant reduction of the current use of freshwater resources, significant steps towards near zero discharge using closed loops in industrial processes, significant increase in the recovery of water, energy, and substances and materials, increase of resources and water efficiency by 30% compared to the state of the art, existing also dissemination and major innovation outcomes, and replication potential of Aquaspace solutions to other cases as well around Europe. Now about something about the circular economy and the circular aspect of Aquaspace. I mentioned before that Aquaspace follows a systemic approach in water management and water efficiency, And this approach and this efficiency can be achieved through an adaptation of technologies and practices in different levels. It's as shown in the figure, in this figure, closed loops of water, substances and energy, mainly water, but we also have the case of substances and energy, can be established and are demonstrated, most of them, on different levels. For example, on a single industrial process, on a unit operation, and this is demonstrated, for example, in case study 1 in Double and international in 2% Turkey. On the entire factory, just like case study 3, BASF in Port of Antwerp, as in collaboration with other industries in an industrial symbiosis manner, just like in games in Slovenia, in a symbiotic action with Agricola, as I presented before, and also in symbiotic actions with some local industries that produce construction materials, where they use the slats and also symbiotic actions with other sectors. For example, in manner of industrial urban symbiosis that is now at the core of Process for Planet strategy. And this is also demonstrated in Solvay case study, where the water that is used is also, there is a link between the Solvay, the industry, the local municipality, and also the Retusa reclamation plan. Finishing my discussion, my presentation, I'm sorry, just a few statements, but also some outcomes that came during the first years of this project is that the challenges are manifold and comprise improved utilization of advanced treatment options, including innovative biological process and membrane separation techniques to remove a broad range of pollutants. This is an outcome came from the technological part, the process innovation, as I mentioned before. The digital solution may have to be developed and tested based on process models before they can be employed to full scale. Now we are exactly in this stage. And also we are in the stage where the real-time monitoring platform has been developed and will be deployed soon. Building digital twins of the industrial systems can help. It's important that we realize it to appropriate assess the different intervention options, technical, economical, and ecological terms. And what is important for this case, and also I'm sure for other cases, for other projects, is that the implementation of all these solutions have also to be accompanied by stakeholder involvement. And this is something that has been encouraged in all 6 case studies in Aquaspace around Europe and Turkey. This is from my part. Thank you very much. And if there are any questions or discussion, we can do that later.
Thank you very much, George. A real pleasure to learn from your project, from Aquaspace. And now we have another project which is particularly important, which is highways. Also, this is a project where Water Europe participates, and it is also under this project that Water Europe basically organized this clustering activity. And well, I mean, I'm more than happy to see again, this time, I mean, in a digital way, Luca Montorsi. We met during the last project meeting in Spain. And well, I mean, give us the insight of this project. We are going to listen to you. Thank you very much.
Thank you, Andrea, for the introduction. Thank you for inviting me to this event and for organizing this event. Highways project. My name is Luca Montorsi, and these are the main figures of the project. The project title is Innovative Water Recovery Solutions through Recycling of Heat, Materials, and Water across multiple sectors. The project coordinator is the University of Modena Reggio Emilia in Italy. We also have a scientific and technical director from the Brunel University London. The budget of the project is close to 13 million euro, and the granted contribution was 10.5 million euro. The project will last for years, starting from December 2020. The main rationale of the project is to develop a set of technologies and systems for industrial processes in order to recover water, heat, and possibly materials from exhaust streams. So we are addressing challenging exhaust streams, gaseous streams, and we aim at recovering water, heat, and materials. So in order to do that, doing that, we are going to realize water closed loops that will allow the reduction of fresh water consumption. We are also recovering thermal energy from the gaseous waste streams, and that energy will be reused in the industrial process. So we are aiming also at reducing the energy consumption of the industrial processes. As I said, we are also aiming at recovering materials from the waste streams. So some substances can be condensed and removed from the condensate and reused in the industrial process, or they are a commodity that can be sold. We are also aiming at developing a real-time smart monitoring system for the gaseous emissions for the waste stream addressed by the project. And we have 3 main demo cases, and we are going through the demo cases now, and these are the objectives for the first demo case. The first demo case is located in Italy. It is a ceramic industry, and we are aiming at condensing water and recovering heat from the spray dryer exhaust gases. The condensate from the exhaust gases will be approximately 500 liters per hour, but we are also aiming at repowering the wastewater treatment of the factory, and that will lead to purify additional 1.5 ton of water per hour. And we are aiming at saving 15,000 tons of water each year, while recovering 6 gigawatt hour per year of energy. And this will lead also to a reduction of the emissions corresponding to 2,500 tons per year of CO2. The second demo case of the project will be Aluflor, which is a chemical industry in Sweden. And this is a very challenging demo case because of the corrosive nature of the exhaust gases. They are producing aluminum fluoride, and the exhaust gases they have in the production process are very corrosive, and we are aiming at recovering the water content in the exhaust stream, along with the other substances that are usually contained in this exhaust stream. And thus we are also recovering substances that can be sold by Aluflor because they are a product for them. By doing this, we are also recovering thermal power. We are aiming at 500 kilowatt thermal power recovery with a total energy recovery of 5.2 gigawatt hour. Just to give you an idea, we are aiming at recovering 70 tons of acid per year instead of releasing it into the atmosphere. The third demo case is located in Spain. It is a steel industry, and this is a very challenging demo case because of the industrial process we are aiming to recover the water and the heat, which is the hot temperature tubes quenching process. So it is a very difficult system where we can locate an heat exchanger, where we can develop a technology for recovering both heat and water. The recovery of heat and water will be coupled with treatment system for the sludge they are having right now in the plant, and thus we are aiming at reducing the final disposal of material. The main technologies that we are going to develop within the project concern three areas. The first one is referring to the heat recovery, and we are going to use a heat pipe condensing economizer in order to recover heat from the gaseous exhaust stream and condense the substances within the exhaust stream. So, for example, here we have a schematic of the heat pipe condensing economizer with a different section. Each section will be characterized by a different temperature of the exhaust gases. So the exhaust gases will reach different temperatures along the heat pipe condensing economizer, and that will allow to condense water and the substances in different sections, so we can more easily recover them. The recovered water and the recovered substances will be treated in order to purify the water and to recover the substances in the condensate. And we are going to use different technologies for the water treatment. Some of them are more established from a technological point of view, while other technologies have a lower TRL. For example, the photocatalytic nanofiltration system has a lower TRL compared to the other technologies, and that system will be tested in a real industrial environment, specifically in the steel industry. The other, as I said, the other treatments are better known, but we are such as reverse osmosis or ultrafiltration, but we are going to use this kind of technologies in industrial sectors where nowadays they are not usually adopted, and that will enable to increase the potential of the water treatment for those industries. The third area where IWACE is focusing is the real-time monitoring of the industrial process. So we are going to develop a decision support system based on a real-time monitoring of the industrial process we are addressing. So we are going to investigate the sensors that have to be installed in order to have a better view of the industrial processes, and the sensors will provide the data to be fed to the decision support system, and that system will enable to take a better decision, to forecast possible problems of the industrial process, and so we can take action in advance before the problem can become more serious. Furthermore, this decision support system will also enable a finer tuning of the industrial process, so we can control it better and we can optimize it, reducing energy consumption and water consumption of the system. So I think that these goals will all move towards a circular economy, and they are compliant with the European Green Deal. By means of the highways project, we are aiming at increasing the competitiveness of the European industry by reducing the energy consumption of the industrial processes, the water consumption of the industrial processes, and enabling circular economy for the industrial processes, because we are going to reuse in the same industrial process the recovered heat, the recovered water, and when possible also the recovered material. These are the directives that are directly linked with the project and with the topics we are working on. And the circular economy is an important topic within the project. We have a dedicated task for the circular economy for enabling the water waste energy nexus. So we are going to develop a unified cross-sectorial circularity model, which will be used not only to define the best strategies for that single industrial process, but it will also enable to investigate possible synergies for different sectors, so we can couple different sectors, different industries, in order to reduce the energy consumption, to reduce the water consumption. So what we recover from one industrial process can be reused in a different industrial process in an industry nearby, where we are recovering the heat, where we are recovering the water. And it will also be used to show different industrial actors or other stakeholders the potential of the water waste energy nexus. These are two images that I'm using to foster further discussion. These are topics where highways project is working on. So low temperature waste streams and complex systems. But I think for these two topics, there is still a lot to do. Also after the highways project, in order to recover heat from low temperature waste streams, or and to recover heat and water from a complex system where it is difficult to build a heat exchanger, and it is difficult to recover the water content from the exhaust stream. This is all from my end. I would like to thank you very much for your attention.
Many thanks, Luca, for your presentation. Well, by the way, I mean, I think that you have seen that I skipped the coffee break. I saw you, I mean, so plenty with stamina, and then I said, okay, let's go ahead and keep, I mean, the attention high on the presentations and on the contents of this great, excellent opportunity that we have together to have all these 5 projects really gathering around the issue of how to effectively manage water for our society. Now we move on to another project that is Interwatt, and I call Andreas Sapalidis to provide us a picture, insights of this 4th project of this call, of the Spark call, and you're welcome to present. Thank you.
Thank you. Thank you very much. So, thank you very much for this opportunity. My name is Andreas Sapalidis, and I'm going to present you briefly the Interwatt project. So the project title, Intelligent Water Treatment Technologies for Water Preservation combined with simultaneous energy production and material recovery in energy-intensive industries. It's coordinated by National Center for Scientific Research Demokritos. The budget is roughly 2.5 million euros, while the project period is 42 months, starting from the 1st of October 2020. The consortium comprises of 20 partners from 8 partners, having 11 companies, industrial partners, and 9 academics. So the rationale, the general concept of the project is to effectively integrate wastewater treatment processes with intelligent and decision-making mechanisms, and to demonstrate these solutions in a series of case studies in industrial environment. The proposed processes will be able to adapt and adjust the treatment conditions in order to minimize the energy consumption while intensifying the volume production of reusable water. Main objective of the Interwatt project is, of course, to validate at the technology readiness level 7 to 8 innovative and intelligent water treatment technologies combining freshwater preservation with resources recovery and energy conversion based on a circular economy concept. This will be demonstrated through 3 different case studies in representative energy-intensive industrial activities, namely power generation, mining, and electroplating. So very briefly, the main expected achieved result at the end of the project will be a zero liquid discharge solution for cooling tower blowdown, energy and water production from mining effluents, and raw material recovery and water reuse in electroplating. So to introduce you to our case studies, our case study number 1 will be hosted by the Public Power Corporation in Greece in a thermoelectric power plant. It's an 800 megawatt combined cycle natural gas power plant, and our goal is to demonstrate and evaluate at TRL 7, which for us means 100 cubic meters per day, a novel intelligent process aiming to at least 99% recovery of the cooling tower blowdown. You can see the sketch of the cooling tower and how it looks in reality, where it's placed in the plant. And just to give you an idea about the amount of water that a thermoelectric power plant uses, the total water circulating flow capacity is 35,000 cubic meters per hour, while the blowdown, which is eventually led to wastewater treatment and then discarded, is roughly at 170 cubic meters per hour. So the water preservation potential here, as you can understand, exceeds the 1 million cubic meters per year, and you can say that it's equivalent to the consumption of 35,000 people per year. Our second case study is a hybrid process for water recovery and energy harvesting from industrial brines. This is a very complex and very interesting case study for us. Actually, we are dealing with a very large environmental issue that occurs next to Barcelona. You can see in the schematic on the bottom of the page. So mining effluents coming from potash mining, maybe this is from the early 1900s, led to a high salinization of the Llobregat River, which eventually led to a very high societal and environmental problem. You can see some very nice presentation in this video that we have prepared for you. It's not easy for me to share it now, but if you press up this link, you will be able to see the problem and how it's dealt at the moment. So our solution there is to harvest energy from the salinity gradient. Then we can take advantage from this very high salinity brines that originate from the mining activities, introducing a reverse electrodialysis solution. So we will be able to produce more than 3 megajoule per cubic meter of treated brine, producing electricity. So this will be equivalent to a reduction of 400 grams of CO2 for each cubic meter of brine treated in our case study. Our case study number 3, it has to do with electroplating and especially plastic electroplating. As you can see on the right of the image, we are dealing mostly with parts that are directed to the automotive industry. All this very nice shiny stuff that we have on our cars start their life as probably dull white or black plastics, but after a series of treatments, they become these very nice shiny items that we are very fond on having in our cars. But in order to do so, a series of electroplating baths are implemented, and they are usually using copper, nickel, and chromium in order to achieve this finish. So the main problem arising from this process is that after each metal is deposited in these parts, a series of rinses is need to be done. And these rinses after a while become more or less contaminated, and this water needs to be treated somehow. So this is where we will intervene, and we will produce, we will develop a technology and a pilot process capacity of rinse water around 2.5 cubic meters per hour. And our goal is to reduce the consumption of fresh water by 65% and reclaim and reuse 95% of copper and chromium and at least 50% of nickel of the electrolytes. And you understand that the significance of this technology is not only economic, it's environmental, and also has a lot of other implications. So, like food for thought, make technological and non-technological enablers and barriers. Of course, when we are talking about wastewater treatment, the first word that comes to mind to every industrial partner is the cost of treatment. And in respect to the existing, let's say, wastewater treatment, the cost is relatively high, and we need always to express it as kilowatt hours per cubic meter treated. Of course, what is need to be done is the seamless integration of the proposed solution in the existing processes. And of course, this again needs to be done through this smart monitoring. Of course, as previous said, the legislation is the main issue, is the obligation for the action. So if there is no obligation to do it, probably a company won't do it. We think that also motivation for the adoption of non-proven technologies on a research and development stage might be very interesting. The knowledge transfer to interested parties needs to be enhanced. Every project follow-up on upscaling and replication needs to be more easily accessed, as well as the public access to proof of concept demonstrators. Contribution to the Circular Economy Action Plan. Of course, freshwater preservation is a very generic process. Cooling towers are found in all the major industrial processes. Raw material recovery and reuse for chromium, nickel, and copper, although these are not listed as critical raw materials. Things, as you understand, are very dynamic, and of course, our application potential will also be involved in how this can be applied to other metals as well. And this, of course, as I told you, has an economic, environmental, and societal impact. Waste valorization on the symbiotic scheme. We will try to incorporate two wastes and producing energy and have some water reclaim above that. Integration of renewable energy sources for water production, zero pollution through waste heat harvesting, integration of smart sensor digitization and monitoring, and water policy relevance. Actually, after a bit of thought, we think that these three quotes, articles from European directive and legislation express us very, very well, that water is not a commercial product, that the water resources of the Union are increasingly coming under pressure, and of course the aim is to achieve the elimination of hazardous substances to be effluent in the marine ecosystem. Discussion statement, again, as some food for thought. We would like to establish a collaboration framework with other projects, probably by organizing technical workshops or public events like this one. We propose joint training activities on our demo sites that are more or less similar to what each one is doing. And another concept is to have side events in major conferences, as more of the projects are membrane technology based. One good opportunity will be the Euromembrane 2022 in November. So thank you very much for this opportunity. I would like to thank all our partners for doing an excellent work in the project, and of course our project officer Ugo Miretti, who I've seen for a while, so it's nice to greet him. Thank you very much.
Thank you a lot, Andrea, for this crystal clear presentation with a lot of inputs and really, points to discuss and to see together. I would like to pass to the last project presentation, which is freshwater, which takes into account the textile industries, which is quite an important industry in the world, and at the same time, we know the risk of pollution. The utilization of water is a big challenge that now the coordinator, Serpil Edebali, will expose us and give us all the insights from this project. Thank you. Please, the floor is yours.
Thank you very much, Andrea. Thank you for your efforts and for Anka also to organize such a clustering event. My name is Serpil Edebali. The acronym of our project is Waste to Fresh, with the full title of Smart Innovative System for Recycling Wastewater and Creating Closed Loops in Textile Manufacturing Industrial Processes. The lead partner of our consortium is Konya Teknik University in Turkey, with a budget of the project about 8.2 million euros for the project period of 36 months. We are 17 partners from 12 countries. You can see our partners of the project. The scarcity of fresh water and pollution of freshwater resources are major societal challenges exacerbated by energy intensive industries such as textile manufacturing ones, which are major users of freshwater resources for processing, washing, diluting, heating, and cooling of the textile materials, which results in the wastewater pollution, polluting the rivers and oceans with the wastewater, which contains chemicals and dyes. And rising this freshwater demand, driving the recovery and recycling of wastewater, and so water pollution arising from energy intensive and high polluting industries is expected to face stricter environmental regulations for industrial wastewater discharge. And breakthrough innovations are needed in such energy intensive industries to recycle water and create closed loop in industrial processes. So the rationale of our project is to deliver closed loop industrial processes in European and global textile manufacturing and other energy intensive industries by using the waste to fresh recycling solution that will considerably reduce industrial water pollution and improve water availability for local communities. From this point, our main objective is to develop and demonstrate a closed loop recycling system for the dye wastewater from textile manufacturing factories by integrating novel catalytic degradation approaches with highly selective separation and extraction techniques, which will assure near zero discharge, which will reduce current use of fresh water resources and which will increase the recovery of water, energy, and other resources. And the main expected results of our waste to fresh is to provide a modular closed loop near zero discharge industrial water recycling system for textile and energy intensive process operations across Europe and worldwide, which will increase resource and water efficiency up to 30% compared to the current state of art. Well, the outputs of related work packages within Waste to Fresh will feed in a front-end engineering design of a large-scale prototype system that will be built and demonstrated at Irak Denim Factory, which is also our one of partners and located in Turkey. Maybe you have heard about its brand name with Mavi Jeans. So for the treatment and recycling of wastewater using a closed loop system, prior to the assembly and demonstration of this large-scale prototype, which we aim to achieve a level of TRL7, the subsystems will be integrated and demonstrated into a relevant environment with wastewater from the Irak Denim Factory. And the performance data from the small-scale prototype demonstration will be used to validate the techno-economic and sustainability targets derived from life cycle assessment and life cycle cost analysis, and if necessary, optimize the large-scale prototype design ahead of its assembly and demonstration at Iraq. The large-scale prototype system will be a real-time monitoring and artificial intelligence enabled monitoring system will be demonstrated to generate performance data that will feed into the LCA and LCCA models and feed package for a future commercial system. The large-scale prototype system will treat 40 cubic meters of wastewater from 2 machines of Iraq per day. And according to an article published by Wall Street Journal, it was mentioned that about 500 gallons of water is used for the production of a single pair of jeans. So this number increases up to 1.3 trillion gallons of water per year annually for the production of fabric dyeing processes alone. So we can say that 20% of global industrial water pollution comes from textile manufacturing. In addition to these problems, issues, also, of course, there are some barriers that might be technically or non-technical for the reuse in circular economy. One of them is the retail brands want to remain one step removed from what is known as textiles' dirty secret. But Waste to Fresh will engage zero discharge of hazardous chemicals program and the large brands to promote the positive impacts of Waste to Fresh system and its overall value proposition, so that they can influence textile manufacturers to adopt the Waste to Fresh solution, helping to change public opinion about the large retailers with respect to textiles' dirty secret. Another barrier might be the opposition to the adoption and use of new technology, and in this case, it might be nanotechnology. Some activities in the project are dedicated to ensuring health and safety aspects are built into the design, development, and operation of all process units and processes combined in the closed-loop recycling system based on nanotechnology. This will ensure Waste to Fresh meets relevant health and safety regulations, helping to facilitate the certification of the system to relevant standards and hence speeding up the adoption. And finally, environmental government policy in Turkey and other target international markets such as Asia Pacific and South America could have a centrist philosophy wanting to treat all wastewater centrally rather than at source on site. And this could hamper the rollout of the solution. But in this case, Waste to Fresh will show what can be done at the local level through the demonstrator and perform both LCA and LCCA to provide evidence for the cost and effectiveness of the solution. And when we look at the new circular economy action plan, we can see that textiles are the fourth highest pressure category for the use of primary raw materials and water after food, housing, and transport. And also the new water reuse regulation in circular economy action plan will encourage circular approaches to water reuse in agriculture, and also the Commission will facilitate water reuse and efficiency, including in industrial processes. So starting from this point, we can say that the Waste to Fresh system will be designed to remove organics, heavy metals, salt, and allowing for each of these to be upgraded as far as possible for reuse. The water will then be recycled for reuse in the factory, following the principles of the circular economy. The energy sustainability for the photocatalytic process unit and other components will be enhanced by using a renewable system of energy generation and storage with appropriate control systems to provide the circular energy needs for operation. And in terms of water policy relevance of Waste to Fresh, the proposed integrated solution fits the circular economy model, as the treated water will be reused within the factory, whilst the other extracted resources such as organic salts and heavy metals will feed into other valuable applications. For example, salts reuse in the same or other dyeing processes. And in terms of water policy relevance, Waste to Fresh addresses the circular economy by developing a breakthrough innovative system, by creating closed loops in energy-intensive textile manufacturing industrial processes, by reducing the use of freshwater sources, by improving water availability in the relevant EU water catchment areas, by offering industrial symbiosis at a scale beyond the textile and other energy-intensive industries, by developing a digitally enabled, that means smart closed-loop system, by achieving a near zero discharge of water and the recovery of energy, salts, and heavy metals in textile manufacturing. And as a discussion statement, we can say that I believe that we will achieve as a consortium these expected results throughout and at the end of the project. And we hope waste-to-fresh system will be not only applicable to the textile industry, but also other energy intensive industries. And at the end of my presentation, I appreciate for the opportunity to speak in this clustering event. Thank you very much.
Thank you very much, Serpil. Crystal clear presentation as well. And I think that today we learned a lot from these 5 great projects. And what I see is that now we enter into the discussion. So I just want me to open this discussion with some remarks. I find that, I mean, each and every project approaches circularity with common pathways, with partial overlapping. But I have a question. I mean, in order to achieve circularity, should we think, I mean, to start from the design or industrial systems in order to achieve, I mean, should we be circular in the design rather than after, or to run after the circularity once that we have already a system for which circularity could be difficult, could require investment? So the question is, are your project also thinking in how to make a difference, not only in creating circularity through, for instance, symbiotic activities, synergic actions between industries and different kinds of industries, but to achieve circularity also starting from the industry design or the process design, starting from the very beginning. So the floor is open. I mean, this is a question that I would like to address to each of you.
So if I may jump first, I think it's what Andrea said is very, very interesting. I guess that what every single project of ours does is finds a problem and then tries to implement a circular, let's say, solution. While what, if I understood it correctly, Andrea, you said that maybe we need to have a different approach on the design initially. I guess that for our case, what we will try to do in every case is to find the most suitable replication that can be applied in a variety of industries, and then this, I think, will be our guide for future development. But as it stands, I think that design is difficult for us to, let's say, implement now. I think what we have done is that we identified the problems and we are proposing solutions. So if I understood it correctly, I think this is how I see it, at least.
So I understand that, I mean, it is difficult. Luca, I think that wants to...
Yes, if I may just add a comment, I definitely agree with you, Andrea, that circularity should be a design criteria, a design criterion from the very early stage of the analysis of the design of our industrial process. But I think that the lesson learned from the projects that have been presented today could be a valuable tool also at the design stage. So when new systems, new plants in the areas where we are working on will be designed, what we are achieving in our project could be used in order to enhance the circularity of new systems, of new designs.
Any other comment on this issue? Because it is interesting, because at the end of the day, I mean, we know what to do, but then, I mean, we also understand that we need, I mean, to start the process, I mean, at a point which will allow us, I mean, to reduce also the investment that are needed for the circularity. But something else, and this is a question that maybe that I also asked to the. Sorry.
Yeah, oh, okay, I'm sorry. I just wanted to add something to the previous question.
Please, George.
Oh, thank you very much. If I understood well, you mean that probably in these projects, 5 projects, some very good designed circular approaches has been defined and are checked now, but probably they are not dynamic enough. They are not somehow expandable or whatever, they cannot be done. So probably we have to move somewhere, either in the process level or in a systemic level or in a digitalization level, where all these circular actions should be somehow germinated, supported, developed dynamically, not having them in mind before. So probably there is a need for a platform, whatever, where all the players or the actors can work together and can have some tools, some specific tools where they can, which can help them in order to come in contact, to find specific opportunities, and at the end create new circular value chains, dynamically in dynamic fashion. This is very important, but probably it's not in the scope of this call. The call that all 4 or 5 projects are under that. It's something beyond that, and probably another project will be demonstrated in more details. However, in talking for Aquaspace project, if you remember, if you also remember, because Water Europe is part of this project, we develop as part of this project a platform related to the industrial symbiosis, where some of these aspects will be taken into account. For example, to come in contact, to find dynamically some symbiotic actions, to find new value chains, to design new processes in order to assist the creation of new value chains, because all these symbiotic actions starting from one end to the other end require some processes in between along the value chain, along the whole value chain.
Thank you very much, George. Any other comments? Please.
Yes, hello. Good afternoon, and thank you very much for all the presentations. Here I am Carolina Rodriguez. I am project advisor of Adair Water. And I would like to put on the table another question, just out of curiosity. Given the circumstances of the COVID, I guess that some of the approaches, technical approaches, and maybe visions of the projects has been adjusted to the current situation, and may happen that what you already planned is not so much as it was planned, maybe in a positive or not so positive way. So I would like to know your feeling, your view regarding what challenges do you foresee at the end of the projects, also within the project. So I am mainly referring to different perspectives or aspects. They may be technical on the management of the projects themselves, but also in view to the markets at the end. So thank you very much.
Well, I think that's, I mean, the market uptake is a big challenge. I mean, the market uptake of the innovative solutions. So this is something that we know. But yes, I mean, I would like to learn from the projects how they see this challenge and the way that this challenge could be addressed. I mean, what should we need in order to jump, I mean, into the market, or I mean, to bridge across, I mean, the so-called valley of death between the innovation and the market uptake? I think that Luca was going to say something, but he's.
Yes, I mean, if I may adjust, I was mainly thinking on changes that has happened, changes on vision that may have happened within this COVID period, if any.
Yes.
If everything continues as it was foreseen, is even better, no? We may say, but I think we have room here to share good practices as well.
I was trying to figure out how the COVID-19 situation will affect the market after the project concerning the demo cases we are working in with the iWaste project. But I think it is very difficult to foresee that situation. For sure, during the first year of the project, we faced many problems, many difficulties concerning the COVID-19 situation, and I guess all projects faced the same issues. Just the difficulty in having in-person meetings. For us, it was really difficult because, okay, you can meet online, but it is not the same thing when you are dealing with the technical issues, especially among partners. They do not know each other well, so they need to learn each other. They need to learn how they are talking about the technical issues. We have also different countries involved, so different approaches to the same problem. And this was a challenge, doing all that online. And also, when it comes to the manufacturing point of view, the lead time of the raw materials are now really long, and this causes an issue for the development of the project. So the impact on the project, on the progress of the project is very clear, unfortunately. How that will affect the market and the market uptake of the technologies that we are proposing, I'm not sure. I want to stay positive. I may say if the market will be more difficult due to the COVID-19 situation, if we are proposing technologies to save energy, to save water, and ultimately to save money, I think it will be, let's say, slightly easier to reach the market if we are proposing a solution that improves the industrial process.
Thank you, Luca.
You're welcome.
Serpil, please.
From the point of waste to fresh, we are aiming to develop a system that deals with the contamination at scale. We can then do tests at the lab level for other industrial applications and feed them into the scale model used. So, for example, we can also test the wastewater for other industrial that has similar attributes, then use the scale-up version. So this is our solution for the challenge.
Thank you, Serpil. George, I see that your hand is raised.
Thank you, Adair. Just to comment a few things on this question about the COVID situation. And so we all know that this COVID situation covered many issues and many problems in our system. So probably the most important one are, apart from pandemic issues and economic issues, are also the social issues. So we need something more in the social aspect, and probably this also belongs to how all these solutions will be uptaken and go to the market at the end. However, we are still in the early stage of all these situations, and we still it's very difficult to forecast what's going to happen. However, all these social aspects and are very important. And there is a need for a social innovation. From a digitalization part is also very important, and now we understood that the human factor is very important. And behind all these industry 4 situations, we need sorry for that. We need also the human factor are more active in this situation. We need trustworthiness. We need all these things, and we're moving probably into a new era of digitalization. And the COVID situation is in a level responsible for that.
Thank you, George. I see that this is also raised his hand. This is or is Andreas that wants to add something to?
Yeah, so regarding the market uptake after the pandemic, I don't feel very optimistic, let's say, about how industries will adapt or will adopt again our, let's say, proposed solutions. I feel that companies are more and more conservative at the moment on how they approach investments in general. So I guess that this brings us in a more difficult situation than it would be without the pandemic. Of course, opportunities are there as well, but my point of view is that at the moment we are facing difficulties than opportunities. And as you see, for example, because we are dealing with the automotive industry, the pandemic was one thing, and now the production is very low due to chips or due to raw materials. Things are very fluid and dynamic, and doesn't look very, very promising, to tell you the truth. Of course, we are optimistic as scientists, but my point of view now is that on the market uptake is that we are facing difficulties.
Well, I think that we need to overcome, the problems and the difficulties. But I would like to take a cue from, I think that from one of your statements before, and you said that at the end of the day, let's say that transition to the circular economy or a circular society, and of course to a water smart society, it's a big game changer. It's not only a matter of investment; it's a matter of changing, really. From the individual, to the society, the legislation, and so on. And remember that somebody said, well, we need to find a good balance between obligations and motivations, which is, quite a difficult balance. But for this particular area, let's say for in industrial water, and we know, how much industries contributes, to the emissions, in the planet. Do you think that, for instance, the revision of the Industrial Emission Directive could be an opportunity to find, a good balance between the obligation and the motivation for the industries, to change, and for the society to change? This, it's an open question, and of course, also to the guests from the Adair. I would like to learn from them.
If I may answer that question, we are not responsible for the industrial emissions directive for the IPPC, but certainly is I can only answer because I was working in GRC in the past in the unit that colleagues were dealing with the IPPC and the industrial emissions directive, the preparatory study, etc. I think it is, first of all, the BREFs are the standards and the best available technologies, and I think the adoption of the best available technologies from the industry really will push the limits for the efficiency, etc. So it's certainly a policy instrument that can help on increasing the efficiency, the recycling, and setting targets with, of course, the stakeholders that are the industry as well. And it's called the Sevilla process. I think it's an open consultation from all industry stakeholders. But I'm not. I was not involved in that, so just from what I know, and certainly, of course, the Horizon projects can contribute into that process and can feed with the results and the main conclusions, and it would be certainly a very useful contribution, and to my opinion is also needed in a way.
Thank you very much, Dimos. Thank you. Also, there is a lot of discussion between what would be more suitable if an horizontal BREF or I mean a better management in each batch, I mean, of the industrial emission directive. Because this is also a difficult balance. I mean, to understand what would be better in terms of achieving efficient management of water, particularly at industrial level.
Because if I may, just to complement, indeed, it's also the BREFs are also on sectors sometimes. So it is also a sector that sees also on sector level that water is also a part of that. Indeed.
Yes, Andrea, if I can expand a bit.
You're welcome.
I wanted to refer a bit to what Andreas said about the issue that now the industry is a bit conservative, so that it's more difficult probably to find large scale investments. I mean, I think here maybe the scientists among you who work in industry could try to take a more active role into highlighting how the new opportunities which will be guaranteed by the recovery fund and many additional funds, the NER 400 and so on, will be linked to a superior environmental performance. So that these good financing conditions, which will be made available soon, in part already now, and for the coming years, so over the lifetime of your projects, usually will be prepared in a way that it's much easier to get access to these funds if you show clearly. And this you can already start doing, of course, doing life cycle assessment and other assessment you do of your technology. If you can show clearly that there is an environmental and in particular, since you also deal with energy efficiency and water efficiency, also a climate change mitigation element to it. So these aspects, of course, are very complex, but your projects are still in the early stages, so you'll have time to develop a strong business case based also on the availability of additional financing tools, which are now probably more easy to access than it would have been in the past, in the sense that one of the criteria for the approval will be the environmental performance. About other barriers, I've seen in your presentations that very often you looked into this already. Of course, financing is one. There are multiple ones. There, my experience would, and this is more than a comment, is a suggestion, more than a question to you, is a suggestion. I think it works very well if you collaborate, you highlight them together, and when they're common, and you prepare a draft position paper, a draft, or even a participation to an event where you present as a group of projects rather than a single one your position. This has been my experience in other sectors. For instance, when the barriers to the implementation of a technology were regulatory in manner, in nature. For instance, with reference to the waste transport directive or to other permitting procedures. I think you will encounter many of those issues in deploying your projects. It was also very interesting, for instance, that Serpil mentioned that in some countries, some solutions are difficult to apply because they want to centralize the water treatment. So, a decentralized on-site solution is some of you are going to develop is going to be very difficult to implement because of this regulatory or, let's say, policy approach. On all these aspects, I think it's very good if you discuss together, you note together those that are common, and then present a common front. And we can help you there to make the point to the policy DGs, which are multiple ones. Of course, it's not only the people who draft the topic or the work program you worked on, it's all the policies DGs which are relevant. So with environment, of course, but also often energy and additional DGs. So on this, yes, please try to work together, and in the coming years, present us with something concrete, a study, a deliverable, a position paper that then we can help you bring forward and influence the regulators on this.
Thank you very much, Ugo. And also, what Europe wants to be supportive to this. To support the projects working together and create one front that can express a strong opinion what should be done in order to support the achievement of the circularity at larger level, because then at the end of the day we should see the problem of circularity not only at industrial level. It is is a societal problem. It's a societal challenge that we need really to address with a systemic approach and view. I see that this is raised his hand.
Yes, sorry for before, but my microphone didn't work. So I want to say something about the market that we spoke before, and sorry about this, but for me it's a very important thing as an SME company that it tends to create some products, from the projects and wants to go to the market. COVID-19, expect that affects a little bit the project's implementation. I think that it will create a lot of problems in the market in the next 3 years. And I'm speaking about this because some shortages are visible to us. Maybe you have heard that it's not possible to find a new car easily and you have to wait for 6 or 8 months because there are no semiconductors. So this affects our lives. For example, as again, so in Axel Water, I have to create a specific hardware. This hardware, if I wanted to cost it when the project started, was X price. Now it's 2X because I cannot find all the necessary components. So I have to find others or to buy the rest ones more expensive. That means the sensors, the membranes, the systems will become more expensive for the industry. So the industry will want to buy something which will be expensive for the next 3 or 5 years. The market, will be stabilized, and after a specific point, the prices will get lower again. But the next 3 or 4 years, I think that we will have a huge problem. And if we will see this energy crisis here in Europe, that the prices are going up all the time, I think that the industries will be very skeptical in buying something. If this question was be done 6 months ago, I would say the market will be okay. But now I'm not sure about the next 3 or 4 years until the situation will be totally stabilized.
Thank you. This is, of course, this hangs shadows. On the sustainability of the results that we are going to achieve through not only these projects, but all the efforts that we do in terms of research and innovation in Europe. Ludo, from your viewpoint, what should be done in order to overcome this problem? let's say, common negative perception that we get from the projects in terms of what will be the opportunities, I mean, to be opened by a possible market.
Yeah, I think that indeed energy is getting a big issue. We are dealing with the energy problems already for a long time in Europe, and now especially with the increasing prices, etc. So every focus on water treatment that reduces the energy consumption and energy costs really makes sense. I think that's the first point. But of course, it goes sometimes a little bit against certain forms of circularity, because every way we try to recover as much as possible elements out of the water to reuse it will go at the expense of certain amounts of energy. So I think we certainly have to focus as much as possible on energy issues so that we reduce energy costs, because that will be really a market issue where every company will listen. And then from there, we must try to integrate as much as possible it also with the recovery of the different elements that are dissolved in the water. But energy is the first, I think. And up to now, we still destroy a lot of energy compounds in the water just by using oxidation, etc. So it's a point, I think, that really makes sense, that we try as much as possible to reduce energy systems, and in some cases it will really need to transition in the water treatment.
Well, I mean, I fully agree. I mean, the transition in the water treatment is more than necessary, it's a must. We have seen, I mean, also, I mean, through the development of the Spire implementation, I mean, now in Process for Planet, I mean, it's really a must, I mean, to think completely, I mean, differently on water treatment. Also because, I mean, I'm taking, I mean, a sentence from the on the regulation 2027 from one, I say water is not a commercial product like any other, but rather a heritage which must be protected, defended, and treated as such. This means that, I mean, there is a real value of water. I mean, it's not a cost. I mean, what we are using is not an infinite resource. But at the same time, I mean, if you really want to say, I mean, how we could remain within, I mean, the planet boundaries. And I remember that someone was saying, I mean, before in a presentation, that we have enough water, but we use it, I mean, in such a bad way that it's not enough any longer.
Yeah.
And it is already not enough. So I mean, it's a big shift, I mean, in the approach. Like, I mean, also there was a statement by Terpit saying that what we do is that we might be still in troubles, I mean, in the water treatment for using the water, because there are too many pollutants that we don't know. So this is the reason for which, before I said, I mean, should we start, I mean, from a bit behind and start, I mean, the design of our systems in order that we achieve circularity more easily. Just a minute point, the BEUC, I mean, the Consumer Association in Europe, does that if we add, I mean, a full circular design of our processes, we might save up to 80% of the resources that we use. Now, I mean, this could be a strong statement. But at the same time, I mean, tells something to us. I mean, it tells us that it is not a trivial portion of resources that we can save and we can spare. And at the same time, I mean, protecting the environment. You know, the environment, I mean, it is not just a cost. So once again, I mean, it's a problem of investment, it's a problem of legislation, it's a problem of changing the attitude of the people. For instance, I think this is before saying that one of the main problems that they were facing was the bureaucracy. And the bureaucracy is something that enters into force and doesn't support, I mean, the transformation again, the circularity. But for instance, my question, I think it is something that belongs, I mean, to national, let's say, shortcomings. I mean, it is something that could be extended, I mean, at larger European level? How can we overcome?
From my side, I think indeed that this is very often seen at a local level, because local authorities are very afraid of changing approaches because they don't know how to manage it. It was mentioned in one of the presentations today. But if we, and that's the strength, I think, of this group of 5 projects, if we see this kind of situations, then it is important to bring them together, and via Water Europe and via P4Planet, we can bring it up to the Commission and really express our concern about certain issues or changes that need to be done, because we are moving from water use in an end-of-pipe system to water circularity, which is completely different, and sometimes out of the comfort zone of a lot of regulatory authorities. So that's a point that we should solve together, I think. And I think there, Water Europe and P4Planet, together with the Commission, can make some statements.
Yes, absolutely, and I think that we can do this. I mean, along with these projects, I mean, yeah, really bringing a lot of experience and a lot of real life. I mean, and something else. I mean, I think it was Luca mentioned the matter that there is the need for communicating. I mean, the need for increasing the capacity of communicating the innovation to the stakeholders, to the citizens. I mean, how this can be done. What kind of instruments we should use? I mean, how we reach, I mean, the citizen, you know, that the citizen might understand that there is a need for making pressure, you know, that change will take place.
I think so that communication about water circularity is extremely important, because in general, people do not like that much circular use of water, because they have all kinds of psychological problems even with it, etc. So we really have to communicate in a strong way and to show examples. And there are so many examples in Europe of reused water, even used for beer brewing, etc. So, and with such examples, we can really convince people that circularity of water is the way to go, and to protect our rivers on one hand, but also to protect the water scarcity on the other hand.
And to protect the oceans, because almost water arrives into the ocean, and it can come from the fresh water. So it's
protecting the rivers is the first point we have to do to protect the oceans. But sometimes people don't see that link indeed. Maybe if you allow me 1 minute, I think also we are used to consume quite huge amounts of waters in all kinds of processes. And now I speak for the process industry. In process industry, I think we have to rely as well on better processes or completely breakthrough processes where we need less water. And that's also a point. And by using less water, we can also move to less energy, because we don't have to heat up all the water in that case, and also to remove less water afterwards as well. So this is also a point that where water projects could move a little bit into the processes and not just see the process as such, and then, okay, now we take the water, we will try to recover everything and we will bring it back in the process. But we need this integration with the process itself as well. And I think there is really a point where Water Europe and P4Planet find each other, or can find each other, to make big changes for the coming calls, certainly. And we can learn from the 5 calls that we have on the desk now strongly how in some cases this can be done.
Well, for sure, I mean, there is our commitment, and I think all the commitment from the projects as well. Going back, I mean, to the matter of the communication, and I found something that was really interesting, in my opinion, at least effective to me, because there are stormy drains in the city areas, whatever. And I remember that in my municipality, I live in Brussels, the municipality started painting some messages, and the message was always the same. The ocean starts here. So it was really impressive. Then, of course, the rain and the sun, cancelled this, and this happened a couple of years ago before the COVID. And it was, a great initiative. So sometimes, the messages are very simple, to be effective. So
exactly.
The reason for which I say that, I think that, as Ugo said before, these projects have really the capacity, they really have, the background, and the opportunity to create, one front where they can really express a strong opinion. And we as Water Europe, we are of course committed to support this process from any angles, as well, to support the process of planets. And of course, the other partnership, Water for All, in which we are also leading one of the pillars, in order really to support projects and our society, to achieve a water smart society.
Fully agree.
Any other comments? I will, because I have a number of quite a few number of questions from the audience that I will address to the project coordinators and to the project officers as well, because some of those questions are addressed to them. And if you allow me, to send them one last message, which is a save the date. We say, why save the date now? Well, it's a save the date. It's an important save the date. We already discussed this with Highways and Luca Montorsi when we met in Spain. And if you allow me to share my screen, we have an event that might be useful for the market uptake. And this is Water Market Europe. That is a matchmaking event. We carry out this on annual basis, sometimes more than once per year. We have a main event that is implemented in Brussels. Then we have road shows that are implemented back to important events that are water related. Of course, with the COVID situation, this has been strongly reduced. But of course, you can see that we are crossing fingers in order to have these matchmaking events that want to put together problem owners and solution providers and investors and policymakers together in order to identify the capacity of the circular solutions for the industrial water efficient management and the industrial symbiosis. This will be the topic of Water Market Europe 2022 on 31st of March in Brussels. And well, we keep, of course, finger crossed in order to make it in presence. If the COVID will still annoy us, we'll make it online. But nevertheless, that will be an opportunity for, but also for the projects with ITRL, to present the solutions, for the solution providers to come and showcase, their solutions, for the problem owners to find solutions and to show their problems. And so, of course, you are invited to participate. You will receive information about this event pretty soon. We are building up the agenda. And what else? I would like really to thank you all. Thank you, the project officers, the project coordinators, Ludo, for the contribution. And I would like really to thank, all the staff of Water Europe that has been, essential in order to plan, to organize, and to implement this project. Really, I would like to thank my colleagues, Anca Popa, Serena Amico, Maria Mirazzi, Anna De Leon, of course, Dirk Krohn, the executive director of Water Europe, Luc Charpentier. All the Water Europe staff contributed to make this event successful and extremely interesting. We will provide you the outcomes of this clustering event, And this, I mean, could be also the opportunity to start building what Ugo said before. I mean, this unique front, and in order to have a capacity to express an opinion, a strong opinion of what should be done in order to better manage our waters in our society. So I thank you all for your participation. Thank you very much. See you, I hope, as soon as possible in presence, and of course, still stay safe.
Thank you very much, Andrea, and thank you to all.
Thank you very much.
Thank you very much.
Thank you very much. Bye bye.
Thank you very much.
Bye-bye.
Bye bye.
Bye.